Hi, I'm Lauren White. In this lesson, we'll talk together about how to predict if an SN2 reaction will actually occur based on the nucleophile and the leaving group. All right, we need to start by thinking about why an electrophile might be willing to substitute in a new nucleophile in place of the leaving group it currently has. And specifically, we're interested in how this would happen through an SN2 mechanism. First, remember that leaving groups are themselves nucleophiles. And so what determines whether or not an SN2 reaction will happen is whether the incoming nucleophile is stronger than the leaving group. It's like two sports teams competing for a big championship trophy. They both want that trophy, but only the team that is better, stronger, faster will win it. In SN2 reactions, if the incoming nucleophile is a better, stronger nucleophile, then the SN2 reaction will proceed. However, if the leaving group is a better, stronger nucleophile, then the SN2 reaction will not happen. Now, in a later lesson, you'll learn all about the solvents we use to perform organic reactions, but for now, know that in aprotic solvents, the ones we use for SN2 reactions, there's a trend for nucleophilicity on the periodic table. So here's our periodic table, and the trend we're interested in is that nucleophilicity increases as we move up a column, and it increases as we move to the left across a period. So we can use this trend to decide if our incoming nucleophile is stronger than our leaving group or not. So let's try it. This question is just asking us, given the reactants, would an SN2 reaction occur, and why or why not? In A, our leaving group is bromine, and our nucleophile is OH-. All right. Let's grab our periodic table. And this is just the right side, so we can see the atoms we need to see. So notice that bromine is right here, and oxygen is right here. And remember, our trend is that nucleophilicity increases up, and it increases to the left. OH, because it has an oxygen, is going to be a stronger nucleophile than bromine. And because of this, we would expect that OH would be able to kick bromine off and replace it on this electrophile. Now, we can also come at this a different way. We can think about the stability of these atoms, and we'll come to this same conclusion. The oxygen in the OH has lots of negative charge concentrated on it. Aside from the full negative charge, oxygen is really electronegative, and so it's pulling electrons away from hydrogen and making itself even more negative. And since oxygen really doesn't like to have so much negative charge on it, this OH- is just itching to react with something. It's unstable. That's why it's such a great nucleophile. Bromine, on the other hand, if bromine were to leave, it would take those electrons with it and carry a full negative charge. Bromine with a negative charge is actually pretty stable. Halogens kind of like to have a -1 charge. Thus, bromine is not going to be a good nucleophile here. At least not as good as OH, because it's very stable. It doesn't particularly want to react. Now, this is exactly why it's a great leaving group, though. It's actually very stable on its own, so it's happy to leave. Now, whether you use the periodic trend of nucleophiles in aprotic solvents, or you think about the stability of the nucleophiles involved, you should now see that with a great nucleophile like OH- and a great leaving group like bromine, this reaction would proceed through an SN2 mechanism. Okay, one more example. Part B has OH as a leaving group and fluorine as its nucleophile. We can use our trend here again. We have oxygen here and we have fluorine here. So oxygen is to the left in that row. And so while both of these could be good nucleophiles, OH is just a little bit better. And it's not likely that a nucleophile like fluorine, even with a negative charge, could displace it. We can also think about the stability of OH. We already said that oxygen doesn't like to have a negative charge. And if OH were to leave in this case, it would take on that negative charge. It'd be making itself less stable. So OH is not going to leave. Again, whether you use the trend on the periodic table or you think about the stability of the atoms, you should come to the conclusion that we have a poor leaving group and our nucleophile is no stronger a nucleophile than our leaving group. So this reaction would not follow an SN2 mechanism. Now, you should feel more comfortable predicting if an SN2 mechanism is going to occur based on the nucleophile and the leaving group.